Hi everyone and welcome back. In this video, I'm going to do a more complicated exercise in propositional logic. So we have the question, prove not the entire quantity C and B from these three premises. So let's get started here. The thing that you want to think about first is how to get to this last place. So I see that it's a C and a B. Well, in these premises, we have an R. So you might want to get rid of that R. Well, the first thing that you might know is to get rid of the R, we could do some operations on these conditionals and maybe make the R's cancel out, so to speak. So let's try that. If you remember the rule of contraposition, you can flip around the conditional and you have to negate both sides like this. Not R, oops, not R. And then let me copy my horseshoe just so I have it. Not C. Right, so all we did, like that. Let's keep it connected. All we did is flip around the R to that side, which is not R, and then turn that to not C. This is called the contraposition rule, if I recall correctly. Oops, cap lock is on. Contraposition of 3. Okay, well, there's a not R, so we can just get rid of that because of double negation. Right, double negation tells us that they cancel out on 4. Okay, well now I have in premise 1 here and premise 5, I have an R at the end and an R at the beginning. So, if you remember the rule, I think it's called a hypothetical syllogism, something like that. You can conclude that the first part leads to the last part, which is like this. A and B, and instead of arrow R, it's actually arrow not C, like that, right? Because we're concluding it through this second premise. So you could essentially think of the R's as canceling out. Okay, so where did I call that hypothetical syllogism? That is on 1 and 5. That's how we got that premise. Okay, so what can we do now? Well, you can turn this hypothetical statement into a disjunction. That's using the implication rule. So let's do that. We do not the first part or the second, right? This is the implication rule. You have to be familiar with these rules, and that's probably why logic is difficult for many people, because the rules are not clear. Well, once you know the implication rule, you can turn any conjunction or conditional into a disjunction. So now we have not the entire quantity A and B, or not C. Well, you might know De Morgan's law, which is about negating a whole quantity. If we do that, we have not A or not B or not C. Now, the thing about this statement is you got to be careful because this is not a well-formed formula. You need to actually have parentheses around where you started. So don't fall for any mistakes there. Just want to make sure I point that out. This is De Morgan's. We'll just say De Morgan's on 7. Okay, we're getting closer, but our answer has C and B, so it probably is a good idea to group these together. And right now we have parentheses around A and B, but these are all disjunctions, which means this is actually associative. You can mix around the parentheses like this, not B or not C, and this is associativity of 8. Right? Associative just means I can move the parentheses around and the meaning is not changed. So this is totally fine. All right, we haven't used premise 2 yet, and I haven't said anything about that yet until now. So we have not A or this whole quantity. Another way of saying premise 2 is by saying not A, right? That's just a double negation on premise 2. Now, why is that important? Well, now I can look, I have a disjunctive syllogism here. I have not A. Well, that's right here, not A. If I can negate that first part, that means the second part of the statement is true. So that would be not B or not C. Cool. This is disjunctive syllogism from 9 and 10. That's a lot of fun. Okay, I don't have B or C. I have actually the other way around. I have C and B. So let's flip it around. Not C or not B. This is called commutativity, commutative property, depending on how you want to say it. 11. Now, it looks like I'm really, really close to my answer, but there's something missing. Well, it's actually De Morgan's law, but in reverse. So you can kind of think about it if you're familiar with math, if you like math, you can think about it as factoring out the negative, like the not symbol. But maybe that's too complicated. So let's double negate the entire thing. I don't know if you want to do it that way. No, I'll keep it the way I did it the first time, which is think about it as factoring out the not. So not C and B, right? This is De Morgan's law. It's the same thing we just did, only it is now in reverse. If I can type this in, my goodness, 12. Okay, well, wait a second here. That's what we were trying to prove. That's the thing we tried to prove, which means this is the answer. Well, the answer is that it is a proof. This is a valid proof. So that's it. So just kind of retrospectively now, let's look at it to make sure it all makes sense. So we started with these three premises, and we first realized that to get to this conclusion, we have to get rid of these R's. To get rid of the R, the first thing we did was focused on the premise that had an R on the end of it, which is the consequent. We changed that around to rearrange it so that it would match well with premise 1. So we used 1 and 5 to get rid of the R's. Now there are no more R's. So we have A, B, and C. Well, that's great, but we only have C's and B's in our conclusion. So we had to use this other premise, premise 2, and make use of disjunctive syllogism to get rid of the A's. That's pretty much what this whole process is, right? Separating it out, flipping things around, and getting rid of that not A is causing us to get rid of this not A. Finally, we have not B or C, not B or not C. And then we just flip it around using commutativity and De Morgan's law to finish it out. We don't need these. And that's the proof. So that's it. Hopefully you got something out of this video. The key is being able to know these rules. I would say just practice them, drill them all the time. Make sure you know them very well, because you never know when something's going to come up. It's just like a toolkit in life. If you only have a screwdriver or a hammer, you won't be able to solve certain problems. That's exactly what logic is about. You need to have the whole toolkit. So that's it for this video. If you liked the video, please like it on YouTube, comment anything I can do to help, any suggestions even. Yeah, that's it. Thanks so much. Bye.